Hi everyone, welcome back to Up in the Air. I'm JP Nicola.
And I'm Hunter Williams. Nice to be back with you.
We have a lot to discuss tonight, ranging from an El Niño's effect on this year's tornado season to unusual trends in lightning strike data.
Plus, students from our weather risk class here in the Department of Meteorology will be by with a look at natural gas and soybean market analysis.
It is finally starting to feel like spring, but unfortunately will not last for long.
That's right. Amanda Reynolds will be by later to break down the 8 to 14 day outlook, but first it's time for Update in the Air.
This year's El Niño, which is a warming of the equatorial Pacific waters, may not only bring a bit of drought relief to the parched western states, but could also deliver a quiet tornado season. New research shows the effects are strongest in Oklahoma, Arkansas, and northern Texas. An experimental forecast from a research team at Columbia University shows a 60% chance for slightly lower risk of tornadoes this March, April, and May. However, as shown in 2013, a relatively quiet tornado season can still provide its share of killer tornadoes. The Columbia research team plans to issue a seasonal tornado outlook as soon as next year. They have analyzed environmental conditions that favor severe weather during El Niño and La Niña years to create a forecasting formula that links wintertime El Niño-La Niña conditions to the probability of severe weather activity during the following spring.
A team of scientists at the University of Alabama in Huntsville has found an unusual trend in lightning strike data. After analyzing data from the U.S. National Lightning Detection Network in tandem with lightning observation networks in Greece and South Africa, the team found that the most powerful lightning strikes occur during the morning hours of the day. Despite differences in relative strengths and lightning frequency, the team found that the peak power spike occurs at the same local time over almost all regions. The team developed a theory tying the rising and setting of the sun to the circulation of the atmosphere, which in turn affects the power of lightning strikes. During the afternoon, where the amount of strikes is at its highest point, the warm air that has been heated all day by the sun rises, carrying with it water vapor, which can turn to ice, along with other particles that can pick up electric charge and make lightning more likely. However, as more strikes occur, the higher number of strikes results in strikes that are less powerful.
The town of Greensburg, Kansas was devastated during the night of May 4, 2007 by an EF5 tornado. It has since been rebuilt as one of the greenest communities in the U.S. Now they're at the forefront of important severe weather research to help better forecast dangerous nighttime outbreaks. Land is expected to be leased by NASA and the U.S. Department of the Navy in Greensburg Business Park for the Pecan Project, which stands for Planes Elevated Convection at Night. Research is critical to improve computer models and in turn save lives as these storms occur in complete darkness. One aspect to be measured is the low-level jet stream, which can be very narrow and difficult to detect by widely spaced daily weather balloon launches. This feature, along with others, will be measured and studied during a 6-week period this summer across Kansas and Oklahoma by more than 20 universities and federal agencies.
A recent study has found that decreased storm activity in large parts of the U.S., Europe, and Russia over the past couple of decades is likely resulting in more persistent heat extremes. The lack of storms is possibly due to climate change and weakened atmospheric circulation, especially during the summer months. Warming in the Arctic appears to be creating less of a difference in temperature between polar regions and the rest of the northern hemisphere. This temperature difference is the driving factor of air motion, and the reduced temperature difference is in turn resulting in reduced circulation and a weaker jet stream, which links to weaker storms. In the summer, storms often transport moist and cool air, which brings relief to long periods of extreme heat. With longer periods of time in between storms, the buildup of heat and drought becomes more likely.
Last week, 4 tropical systems were churning in the Pacific Ocean and provided a prime example of Earth's larger atmospheric connections. 2 of the storms formed on opposite sides of the equator and were practically mirror images of each other. This is normally in response to a strong pulse in the Maiden-Julian Oscillation, or MJO. As Jeff Masters, co-founder of Weather Underground, explains, the MJO is a burst of energy that moves through the atmosphere the way a ripple will run through a snapped bedsheet. This looks to be one of the 4 strongest MJOs since 1974 and will help strengthen the high-pressure ridge near Alaska, which means more cold for the eastern U.S.
A new study on snowfall in Antarctica confirms that snowfall would likely increase with continued temperature rise, offsetting future sea level rise from previous sources. Scientists have long believed that when more snow falls on land, more snow melts into the sea. However, this is not always proven to be the case. The scientists found out that from 21,000 to 10,000 years ago, for every degree of warming, there was a 5% increase in Antarctic snowfall. The added weight of that snow would have increased ice flow into the sea, resulting in less of a limiting factor on sea level rise. In the end, the study has determined that increased snowfall in the Arctic would still have a limiting effect on sea level rise, but that the limiting effect could be up to 20% less than previously thought. That's all for Update in the Air. We'll be back in a moment with more. Welcome back to Up in the Air.
We have another market analysis for you this week as Helen Guza and Corey Barwat tell us more about the natural gas and soybean commodities.
Hi, I'm Helen Guza.
And I'm Corey Barwat.
We're here to update you on the soybean meal and natural gas futures.
Natural gas prices have been trending lower ever since we have been on spring break, thanks to a change in the weather pattern.
The soybean meal futures have also seen some changes. Let's take a look at what's happened to the soy meal prices between March 8th and 14th. Currently, the soybean growing process is about 50% complete in Brazil and just beginning in Argentina. Last week, the May contract for soybean meal prices started out staying fairly consistent. However, on Friday, March 13th, the market saw a strong bearish trend with prices. This can be seen by the current stock price of $323.6, which is much lower than the 20-day average of $334.1 and the 100-day average of $337.5. The World Agricultural Supply and Demand, or the WASDE report, was released last Tuesday at noon by the USDA. The report stated that the projected supply of soybeans for the season will remain unchanged from February's report. Brazil's soybean crop remained at 94.5 million metric tons, and Argentina's crop remained at 56 million metric tons. The soybean crush and exports also remained the same as forecasted. This caused the market to stay fairly consistent for the beginning of last week. The market saw a drop in soybean meal prices on Friday. A factor that has most likely contributed to this drop is the strength of the U.S. dollar against other forms of currency. On Friday last week, the U.S. dollar climbed 0.9%, reaching 100, which is the highest value it has seen since April 2003. The Brazilian real has simultaneously seen a drop to its weakest value since 2004. This means that soybeans and other foreign commodities will have lower values when traded in dollars. This will most likely cause the price of soybean meal to stay low. Let's take a look at the weather in South America. Over the past month, Argentina's rainfall has been approximately average, whereas the major growing region of Mato Grosso, Brazil, has been slightly drier than average. Temperatures in Brazil for the next week are projected to be just slightly cooler with a typical precipitation. On the other hand, Argentina is expected to have warmer and drier weather.
The week of March 8th through the 14th saw much warmer temperatures than the first week of March. Natural gas futures fell in New York, capping a weekly decline, as milder U.S. weather hindered demand for the heating fuel. Forecasts showed that above normal temperatures across the contiguous U.S. through March 18th will give way to a weaker push of cool air the following 10 days. With the cold now isolated in the Northeast for the rest of the month, the resulting heating demand will likely not offset production. The early start to the injection season has reignited selling interest throughout the market. Production of the fuel will climb in 2015 for the 10th straight year, rising 5% to 78.39 billion cubic feet a day from the previous year. The government raised its growth estimate from 3.1% in the December report. Natural gas NYMEX contracts for May were at a high point of $2.92 in the middle of last week. However, these prices have continued to drop after the warm temperatures to $2.80 at closing on Monday. This indicates that gas supplies are more than able to meet demand. The U.S. Energy Information Administration said that natural gas storage in the U.S. fell by 198 billion cubic feet last week to 1.512 trillion cubic feet. This is 46.9% above year-earlier levels and 13% below the 5-year average for this time of year. This indicates producers have made up for most of last winter's unusually strong demand.
We hope you enjoyed our market analysis and found something informative about the update.
For Up in the Air, I'm Corey Barwat.
And I'm Helen Guza.
Welcome back.
We will now be joined by a student from our weather communications class to talk about how clouds affect the temperature.
It's no mystery that temperatures are warmer on a clear day and cooler on a cloudy day.
Clouds aid in the rising and falling of temperatures, but how much do they actually affect the Earth's surface temperature? The individual effect of a cloud depends on factors such as its height, thickness, location, and whether it's day or night.
The temperature that we feel on Earth's surface is due to a balance between the incoming solar radiation and the emitted radiation from our planet. During the day, the Earth is heated by the sun. If skies are clear, more heat reaches the Earth's surface. This leads to warmer temperatures. However, if skies are cloudy, some of the sun's rays are reflected off the cloud droplets back into space. Therefore, less of the sun's energy is able to reach the Earth's surface. This causes the Earth to heat up more slowly and leads to cooler temperatures. Thin clouds reflect 30 to 50% of incoming solar radiation, while thick clouds reflect up to 90%. Generally, thin and wispy high-altitude clouds, such as cirrus clouds, do little to block incoming sunlight, but do trap outgoing heat, having a net warming effect. Low-altitude clouds, such as stratocumulus clouds that form over cool ocean waters, tend to have a net cooling effect. Deep convective clouds tend to be neutral. At night, cloud cover has the opposite effect. If skies are clear, heat emitted from the Earth's surface freely escapes into space, resulting in colder temperatures. However, if clouds are present, some of the heat emitted from the Earth's surface is trapped by the clouds and re-emitted back towards the Earth. As a result, temperatures decrease more slowly than if skies were clear.
Welcome back. We returned to quite a nice warm-up here at Penn State after spring break.
Yes, it was nice to see the grass for the first time in a few months.
Indeed, but it probably has many hoping that this spring-like pattern continues.
That's for sure. Amanda Reynolds is here now with our climate outlook.
Thanks, JP and Hunter. Although this week did begin unseasonably warm, that warm air did not stick around. I'm student meteorologist Amanda Reynolds. We begin by taking a look at the current snow cover. Along with that warm air, we experienced quite a bit of melting. This map is significantly different than what we've been seeing over the course of this winter. Currently only 12% coverage of snow in the United States, and most of that is the extreme northeast, which had feet upon feet of snow dropped early this winter, and areas in the Rocky Mountains. Areas up in Wyoming still have up to 3 feet of snow in some areas, while areas of the southern Rockies are actually having problems that they do not have adequate snowpack for a lot of the skiing areas that have been there, and they're at a record minimum for the amount of snowpack, and that has caused issues there. And again, here in the Northeast, most of the areas have seen significant melting. Here in State College, just a few traces of that snow, while areas again to the north and east still have up to about a foot of snow up in extreme northeast Maine. The temperature outlook for the next 8 to 14 days, much of the eastern United States expected to be below normal. Areas of New York and Maine and the extreme northeast are expected to be well below normal temperatures over the next week to 2 weeks. State College slightly below normal, along with, again, most of the eastern United States. It's exactly the opposite in the western part. They've had extreme record drought and record high temperatures, and that is not going to be different, as we are expecting well above average temperatures in the western parts of the United States, areas of California, Oregon, and Washington, well above normal, and that will not help that drought or extreme warm temperatures at all. Looking at our precipitation outlook for much of the East Coast, again, above normal precipitation we are expecting over the next week to 2 weeks, along with areas in the north central part of the United States. While again, areas of the Southwest, more drought is expected, below average precipitation, and that will not help that drought at all. Parts of the North Pacific, we are expecting to have above normal temperatures. I'm student meteorologist Amanda Reynolds. Back to you, Hunter and JP.
Thanks, Amanda, and thanks to you for joining us this week.
We hope you enjoyed this week's episode filled with plenty of content from students here at Penn State.
Be sure to join us next week for more work done here by students in the Department of Meteorology. I'm Hunter Williams.
And I'm JP Nicola. We'll see you next week up in the air.